pharma chemistry video. If you are new to this channel, please refer to our basics video on medicinal chemistry. Okay, if you go to that video, you will come to know that every class of drug, like for example anxiolytic, like sedative and hypnotics, okay, any class of drug require a basic structure known as pharmacophore. Okay, over here to discuss CNS acting drug, we will be discussing the first pharmacophore known as benzodiazepine. So if I draw a benzene and then diazepine, so the structure become like this. Okay, now I can put a double bond over here, okay, that become benzodiazepine. But with this basic pharmacophore, let me draw a first prototype of drug known as diazepam. Okay, this is the extra fabrication I am doing in the pharmacophore. So this is the basic structure of diazepam. Now what is the numbering? Numbering starts with 1, 2, 3, 4, 5, 6, 7, 8 and 9. This is the basic understanding of diazepam. Diazepam structure. So what is the SAR of these particular anxiolytics? First mechanism of action, they are GABA A agonist. This pharmacology already have described in our earlier video, so please refer to the CNS videos. So now first pharmacophore, the SAR is the introduction of this chlorine group is very important for activity. The 7th chlorine, okay, it increases the lipophilicity. There are other groups like nitro groups also present in the other benzodiazepine analog like nitrazepam. Nitrazepam contains 7 nitro group, okay, and even this methyl group is not present. So if you remove the methyl group from diazepam, it becomes nordiazepam. Okay, so 7 nitro and then 1H nordiazepine is nitrazepam. It's also used for epilepsy, and nitrazepam possesses skeletal muscle relaxant activity. Now diazepam also used to treat status epilepticus disease that we have already discussed. It is used to treat seizure, panic disorder or akathisia. Okay, now if you see 7 nitro group, okay, without a methyl group over here, and if you add a chlorine, okay, then it is chlorine and nitro diazepam known as clonazepam. Okay, so clonazepam is also used for seizure and panic disorders and akathisia, and actually this is more useful for panic disorders and akathisia than diazepam. Diazepam more sort of to the status epilepticus. Okay, but this drug is having the withdrawal symptoms. Then you have a next drug known as the next SAR point, the second SAR point. NO2 is more preferred over bromine, trifluoromethyl and chlorine. Even chlorine increases the lipophilicity. Electron withdrawing group of chlorine group is essential for activity. Then 2-ketone group is essential for interacting with histidine residue of the GABA A receptor. Then 3-hydroxy group like oxazepam, okay, it's having relatively less T-half because it is more polar, can be excreted more faster from the body. Okay, 5-phenyl group is required for aromatic interaction with the receptors. Now with the help of this SAR, there is another important drug of diazepam, that is your with this structure NHCS3 and 1 oxide. This is known as chlordiazepoxide. Chlordiazepoxide, the structure. Okay, so what is the use of chlordiazepoxide? It can be used for alcohol withdrawal, but it contraindicated in myasthenia gravis. Okay, chlordiazepoxide. Then one more contraindication for nitrazepam I forgot to say, it is COPD, and all diazepam should not be given with the erythromycin. Okay, because of the metabolic effect that we will be discussing in our metabolites video. Okay. Now the temazepam is 3-hydroxydiazepam. So if diazepam, if it is 3rd hydroxy, it will become temazepam. Okay, and it is contraindication with ataxia. So and oxazepam chemically is 3-hydroxy-nor-diazepam, right? So now coming to the next diazepam analog that I have drawn over here, the first structure as an anxiolytic sedative hypnotic drug known as alprazolam. Okay, that drug is known as alprazolam. This is very famous as a sleeping pill. Okay, Schedule H drug. Without prescription you cannot be get from the medical store. You can't get. Okay, so this structure, if you see, it is a triazole ring, right? And if you introduce one chlorine over here, it become the next drug under the triazolobenzodiazepine known as triazolam. Okay, so this is a second drug, and without the methyl group, if you see in a alprazolam, without this methyl group, it's known as istazolam. These are the things is important to know. Now recent guideline of NTA says that there should be 38 questions from pharmacochemistry. It can be, goes ups and downs, but first time in the history of GPAT 2021 there will be a lot of pharm chemistry questions, which include organic chemistry, physical chemistry, analysis, and the medicinal chemistry. Okay, so then after that you have the drug known as midazolam. Midazolam, if you remove this nitrogen, okay, it becomes imidazole benzodiazepine with one fluorine group. Okay, it becomes midazolam. Midazolam is exclusively given in IV to treat status epilepticus. Okay, so midazolam. After that you have the basic drugs is over for diazepine. Now we'll go to the next diazepine analog. But now you must remember the benzodiazepine is a weak basic drugs. Okay, weakly basic drug. So for Henderson-Hasselbalch equation, pK minus pH is equal to ionize upon ionization. So over here the pH is 7 for blood pH. So pK of benzodiazepine should be below 7 in order to become unionized in blood, so that they can enter blood-brain barrier, enter into the CNS. So this is one of the important part of the SAR. Okay. Then coming to the next drug, which is not mentioned currently in the University of Mumbai syllabus, but it is very important, which is known as barbituric acid. Okay, barbituric acid. Yeah, I'm correct. This is R1, R2. Now if you see the barbituric acid is weak acid. So the Henderson-Hasselbalch equation, pK ionized upon ionization. So pH 7. So the pK of barbituric acid should be more than 7 in order to, less than 7. Okay, in order to remain unionized form in the blood pH. See the difference, pK minus pH for benzodiazepine. So over here benzodiazepine pK should be less than 7. Okay, so that the difference will be negative, so ionization is more. Now pH is 7 already. Okay, so the pK pK should be more than 7. pK should be more than 7, so it will be like maybe 7 minus 8. Okay, 7 minus 9, so it become minus 2, so its ionization is more. So for barbituric acid the pK is